In 2020, we introduced the Gemera, our first four-seater hyper or mega car as we call them. A completely novel idea to anything out there in the world.
A motor so compact, it fits in a backpack. So powerful, it launches a four-seat family car faster than a Bugatti. No transmission, no noise, no wasted energy, just pure, instantaneous force. This is dark matter, the world's first six-phase automotive electric motor, and it's about to rewrite everything we thought we knew about electric propulsion. How did a small Swedish company achieve what billion-dollar giants couldn't? And why are Tesla, Porsche, and BYD suddenly paying attention? Stay with us to discover the engineering breakthrough that's changing the game. The engineer who defied convention. While Tesla dominated headlines and legacy automakers poured billions into electrification, one Swedish engineer quietly rewrote the rulebook. Christian von Koenigsegg doesn't follow trends, he demolishes them. His story begins at age 5. When most kids were playing with toys, he was disassembling them to understand their mechanics. That same year, he made a declaration most adults dismissed as childhood fantasy. I'm going to build the fastest car in the world. 40 years later, he proved them all wrong. In 1994, with no investors, no factory, and no safety net, he founded Koenigsegg Automotive. When he unveiled the CC prototype, industry experts couldn't believe a small workshop in Sweden had created something so radical. But that was just the beginning. While others added gears, Koenigsegg eliminated them with direct drive technology.
So I actually started my first company when I was 19, buying and selling plastic bags, ballpoint pens, frozen chicken, just trying to make some money so that I could build a car. 3 years later, when I was 22, I had made a little bit of money. So I started, and 2 years later, I had a driving prototype that still drives around today.
When competitors built bigger engines, he created smaller ones with revolutionary free valve technology, software-controlled precision that redefined efficiency. While the industry relied on steel, Koenigsegg pioneered carbon fiber monocoques, so advanced they reset crash safety standards. Every breakthrough emerged from one simple question: why are we doing it this way? That defiance transformed a modest Swedish workshop into a company that makes Ferrari cautious and Bugatti nervous. From the CCR's world speed record to the Agera RS hitting 278 km/h to the Regera's transmission-free hybrid system, Koenigsegg has never stopped pushing boundaries. But for Christian, speed was never the ultimate goal. It was proof of concept. So, when the automotive world rushed toward electrification, he asked a different question. What if everything we know about electric motors is fundamentally wrong? That question led to years of secretive development. The result shattered every assumption about electric propulsion. They called it dark matter. When the specifications were finally revealed, competitors checked their calculations multiple times. The numbers seemed impossible. Why the name matters. Koenigsegg could have chosen a conventional name: Power Core, Hypervolt, Electroforce. Instead, they chose dark matter, and the reason reveals everything about what they built.
We can turn the engine into a flamethrower at cold start with the help of the valve timing to heat up the catalytic converter like this. And 90% of the emissions from a combustion engine comes the first 20 seconds before the catalytic converter is warm.
In physics, dark matter is the invisible force holding galaxies together. Scientists know it exists because they can measure its effects. Galaxies rotate. Stars maintain their orbits, cosmic structures hold their shape, yet dark matter remains completely hidden, influencing everything through pure, invisible strength. Koenigsegg's motor operates on the same principle. It's compact enough to hide in unexpected spaces. It runs silently, no roaring engine, no mechanical drama. From the outside, it appears almost ordinary. But the moment it activates, everything changes. The car doesn't just accelerate, it transforms. It launches forward with supernatural force because there's no warning, no sound, no indication of the power about to be unleashed. Most electric motors telegraph their capabilities. You hear cooling fans spinning up, feel the weight of massive battery packs, sense the bulk of the drivetrain. Dark matter eliminates all of that. The name isn't marketing creativity, it's technical accuracy. Like cosmic dark matter controlling galactic motion invisibly, Koenigsegg's motor delivers extraordinary performance without the bulk, weight, or noise typically associated with this level of power, which raises the inevitable question: just how powerful is it? Specifications that defy physics. Imagine lifting something that weighs as much as a carry-on suitcase, just 39 kilograms. Now, imagine that object produces 800 horsepower and 1,250 newton meters of torque. That's dark matter. The numbers seem impossible because they violate everything the automotive industry has accepted as normal. The power-to-weight ratio tells the real story, approximately 20 horsepower per kilogram. Most production EV motors deliver 3 to 4 horsepower per kilogram. Dark matter multiplies that standard by 5. Let's put this in perspective. Tesla Model S Plaid uses 3 motors totaling 90 kilos to produce 900 horsepower combined. Dark matter delivers 800 horsepower from a single 39 kilo unit, matching 3 Tesla motors with less than half the weight. Rimac Nevera, one of the world's most powerful electric hypercars, uses 4 motors exceeding 150 kilogallon combined to produce 1,114 horsepower. Dark matter achieves nearly half that power, at roughly 1/4 the weight. Porsche Taycan Turbo S motors produce 750 horsepower from approximately 100 kilon of hardware. Dark matter exceeds that output while weighing 61 kilon less. These aren't incremental improvements, this represents a generational leap, but raw power is only part of the story. Dark matter's maximum rotational speed reaches 8,500 RPM, delivering instant torque across the entire rev range. No lag, no buildup, no waiting. Press the accelerator and full power arrives immediately. The physical dimensions are equally remarkable. 15.1 inches in diameter, 5.3 inches thick. You could stack 3 of them and still have less height than a standard car tire. These specifications demand explanation, and that explanation lies in technology the automotive industry had never seen before. Koenigsegg had to invent it. Raxial flux, the breakthrough technology. For decades, electric motors have followed 2 distinct architectural paths, each with clear strengths and unavoidable compromises. Radial flux motors, the most common design, found in everything from power tools to Teslas, feature a rotor spinning inside a stator with magnetic flux radiating outward like wheel spokes. They're mechanically simple, easy to manufacture, and excellent at high speeds. But to increase torque, you must make them longer, adding weight and creating packaging challenges. Axial flux motors take a completely different approach. They place the rotor and stator face-to-face in parallel planes, like 2 discs with magnetic forces acting parallel to the axle. This pancake configuration delivers higher torque density in a more compact package. But they're complex to manufacture, difficult to cool, and typically don't handle high speeds as well as radial designs. For decades, engineers chose one path or the other based on their priorities. Koenigsegg refused to choose. They merge both. They call it Raxial flux, a term they coined because no existing vocabulary described what they'd created. Dark matter's Raxial design layers rare earth magnets in a configuration generating both radial and axial magnetic forces simultaneously. The rotor and stator interact in multiple planes, channeling magnetic flux in 2 directions at once. The result captures the high-speed capabilities of radial designs while maintaining the torque density advantages of axial configurations, delivering maximum torque across the entire RPM range without traditional compromises. The engineering challenge was immense. Managing magnetic forces in 2 planes simultaneously requires precise control to prevent interference and energy loss. Koenigsegg solved this through advanced finite element analysis and iterative prototyping, mapping every magnetic field line to optimize flux paths and eliminate energy-dissipating dead zones. Material selection was equally critical. Dark matter uses rare earth neodymium magnets, among the strongest available, arranged in precise geometric patterns, maximizing field strength while minimizing weight. The stator windings employ high-grade copper with optimized conductor cross-sections. Every component uses aerospace-grade materials. Carbon fiber, reinforced polymer rotors, withstanding extreme centrifugal forces at 8,500 RPM. Carbon fiber composite housings, providing structural rigidity while efficiently dissipating heat. This construction achieves approximately 95% efficiency under optimal conditions. Only 5% of electrical energy converts to waste heat. Compare that to typical EV motors operating at 85–90% efficiency. Higher efficiency means less wasted energy, smaller cooling requirements, extended range, and sustained performance under loads forcing conventional motors to throttle back. But Koenigsegg didn't stop there. Hidden inside dark matter is one more innovation that fundamentally changes how electric motors operate. If you're impressed so far, hit that like button. It helps us reach more engineering enthusiasts who appreciate true innovation. Six-phase power, smoother, stronger, smarter. While the entire EV industry runs on three-phase power, because that's how it's always been done, Koenigsegg asked a simple question. What if we doubled it? Every EV motor relies on electromagnets in the stator, switching on and off in sequence, creating rotating magnetic fields that pull the rotor around. The more phases you have, the smoother that rotation becomes, and the more efficiently power flows. Three-phase systems have worked fine for decades in industrial applications and mainstream EVs. They're proven, reliable, and relatively simple to control. But they have limitations that become apparent when pushing power density to extremes. Under heavy loads, three-phase systems experience torque ripple, small fluctuations in rotational force, as each phase takes its turn driving the rotor. You feel this as subtle vibration during hard acceleration. Three-phase motors also concentrate current through fewer pathways, generating more heat per conductor and requiring aggressive cooling. If one phase fails, the motor immediately loses 1/3 of its capacity. Koenigsegg's six-phase architecture changes everything. Instead of 3 electrical phases, dark matter uses 6, arranged as 2 sets of 3-phase windings offset by 30 degrees. This doubles the number of current pathways pushing the rotor at any moment. The benefits permeate every aspect of operation. Torquey ripple virtually disappears. 6 phases create such smooth, continuous rotation that fluctuations become imperceptible. Current distributes across twice as many conductors. Each wire carries less amperage, generates less heat, operates further from thermal limits. Improved thermal performance, the motor sustains peak power longer without triggering protective throttling, enhanced fault tolerance. If one phase fails, 5 others continue operating, maintaining approximately 83% power versus 67% in 3-phase systems. This electrical sophistication demanded an equally advanced control system, which is where Koenigsegg's next innovation becomes critical. The David inverter, the brain behind the brawn. All of dark matter's power and sophistication would be worthless without 2 final pieces: a brain fast enough to control it and cooling sophisticated enough to prevent self-destruction. The David inverter is that brain. Inverters convert DC battery power into AC current that drives motors. But calling David just an inverter undersells what it actually does. This silicon carbide unit makes over 100,000 decisions per second, constantly adjusting current flow to each of dark matter's 6 phases based on throttle position, motor temperature, wheel slip, and dozens of other variables. Silicon carbide was critical. Unlike traditional silicon semiconductors, silicon carbide switches faster, handles higher voltages, and operates at higher temperatures without degradation. This allows David to react in microseconds rather than milliseconds, eliminating the lag between driver input and motor response plaguing many EVs. When you press the accelerator in the Gemera, David has already calculated optimal current distribution and begun adjusting power flow before your foot finishes moving. David's capabilities extend beyond simple power conversion. Manages torque vectoring by independently controlling current to different phases, monitors thermal conditions, and adjusts power delivery to prevent hot spots. Coordinates with the transmission to ensure seamless power flow during gear changes. Every electrical decision flows through David, making it as essential to dark matter's performance as the motor itself. But even the smartest control system can't overcome thermal physics. 800 horsepower generates tremendous heat. And in a package as compact as dark matter, that heat can become destructive if not managed aggressively. Koenigsegg developed a liquid cooling system, circulating coolant through channels embedded directly in the stator housing, just millimeters from the copper windings where heat generation is highest. The cooling circuit uses high-performance thermal fluid-absorbing heat more effectively than water-based coolants, carrying it to external heat exchangers. The system maintains optimal operating temperature even during sustained full-power runs, preventing the thermal throttling affecting many performance EVs after repeated hard accelerations. Every design decision, from phase count to magnetic architecture to cooling circuit layout, works together to keep dark matter operating at peak efficiency under conditions that would destroy conventional motors. The Gemera, where everything comes together. Koenigsegg took the world's most advanced electric motor and installed it in the last place anyone expected, a 4-seat family car that happens to outperform every electric hypercar on the planet. The Gemera looks civilized at first glance. 4 proper seats with legroom for actual adults. 8 cup holders, 4 heated, 4 cooled. Because apparently if you're building a hypercar, everyone deserves their beverage at the perfect temperature. Luggage space front and rear, climate control for all passengers, individual infotainment screens. These are details you'd expect from a luxury sedan, not from a machine capable of violating physics. But underneath that practical exterior hides something unprecedented. The Gemera is the first production vehicle powered by dark matter, paired with engineering just as radical as the motor itself. The Light-Speed Tourbillon (LST) transmission is a 9-speed multi-clutch gearbox that doesn't shift like normal transmissions. It preloads the next gear while the current one is still engaged, then transitions between them so quickly that torque flow never interrupts. Every gear change feels like one continuous surge of acceleration. Dark matter mounts in the front axle assembly, what Koenigsegg calls the Bulldog drive unit, delivering instant torque to the front wheels. The real power comes from behind, where the hot V8 produces 1,500 horsepower and B&A's 500 Newton-meters on its own. When dark matter joins the equation, total output reaches 2,300 horsepower and 2,750 Newton-meters of torque. Those combined figures exceed every production car in history. Bugatti Chiron Super Sport, 1,577 HP Rimac and Nevera, 1,914 HP Koenigsegg, Gemera with hot V8 2,300 HP. Yet the Gemera can cruise silently on electric power, alone with 50 km of pure electric range from its 16.6 kWh battery pack, slip through city traffic without drama, and deliver better than 7 liters per 100 km fuel consumption when driven reasonably. Performance numbers reflect this absurd power. 0-100 km/h, 1.9 seconds top speed, over 430 km/h. It's simultaneously a hypercar, a grand tourer, and a practical four-seater that happens to be faster than anything else on public roads. The competition that suddenly looks outdated. The electric vehicle industry has operated on one fundamental assumption. Maximum performance requires maximum hardware. Koenigsegg just proved that assumption wrong. Tesla Model S, Plaid, 3 motors, 90 kg combined, 1,020 horsepower. Dark matter alone produces 800 horsepower at 39 kilos, delivering comparable performance with less than half the weight. Rimac Nevera, 4 motors, over 150 kilos combined, 1,914 horsepower. The Gemera produces 2,300 horsepower while weighing less than 2,000 kilos total, achieving superior power-to-weight ratio despite seating 4. Porsche Taycan Turbo S, dual motors, approximately 100 kg combined, 751 horsepower. Dark matter exceeds that output while weighing roughly 60 kg less, and the Taycan can't match the Gemera's versatility, range, or outright performance. The pattern is clear. Mainstream and luxury EVs alike use multiple motors, accept greater weight, and design around limitations Koenigsegg simply eliminated. Dark matter's power density advantage cascades through every aspect of vehicle design. Lighter motors enable better weight distribution, improved handling, reduced energy consumption, and design freedom multi-motor layouts can't provide. Every automotive engineer who sees these specifications now knows something better is possible. And that knowledge alone will push the entire industry towards solutions current leaders may not be prepared to deliver. But the threat isn't just about cars anymore. It's about every application where electric power matters. Beyond automotive, the revolution. Nobody expected. While everyone debates whether dark matter threatens Tesla and Porsche, they're missing the bigger picture. This technology could transform every industry where power-to-weight ratio matters. At 39 kg and 800 horsepower, dark matter fits in spaces no conventional power unit could occupy. That combination doesn't just change cars, it opens possibilities across industries that have waited decades for this breakthrough. Aerospace. Electric flight has been limited by weight. Batteries are heavy and traditional motors too bulky for aircraft applications, where every kilogram matters. Dark matter's 20 horsepower per kilogram ratio changes that equation completely. Distributed propulsion systems could power aircraft previously impossible with electric technology. Urban air mobility companies developing flying taxis need exactly this power density. Marine applications. Electric boats need high torque, but can't afford heavy drivetrains that raise the hull and increase drag. Dark matter delivers marine-grade torque in a package light enough to improve rather than compromise boat dynamics, benefiting high-performance racing boats, commercial vessels, even submarines. Industrial robotics. Manufacturing automation requires motors that run continuously without overheating. deliver precise torque control, and maintain reliability over millions of cycles. Dark matter's thermal management and efficiency characteristics make it ideal for applications where downtime costs money and consistency matters more than peak output. Heavy lift drones, construction, logistics, and emergency services need sustained high power in weight-optimized packages. Exactly what dark matter provides. Koenigsegg designed dark matter with scalability in mind from the beginning. The company produces most components in-house, giving them complete supply chain control and flexibility to adapt the design for different applications without relying on third-party suppliers. As production volumes increase, manufacturing costs will decrease, making the technology accessible to industries beyond automotive. Whether Koenigsegg licenses the technology, supplies motors directly to other industries, or keeps it proprietary for their own vehicles, dark matter represents a fundamental breakthrough, extending far beyond the hypercar market. The question now is, will this motor soon challenge giants like Tesla and BYD? Will its technology find its way into the cars we drive every day?